Chapter 13, Fluids. This lecture will help you understand buoyancy in a liquid, Archimedes' principle, buoyancy in a gas. Buoyancy is the ability of an object to float in a liquid. Buoyancy is also the apparent loss of weight of a submerged object. The buoyancy force equals the weight of water displaced. If an object displaces more water than its weight, it will float. Dense objects sink in fluids of lower density. A rock sinks in air or water, and oil floats on the top of water. Basements stay cool in the summer because cool air is denser than warm air. Archimedes' principle was discovered by the Greek scientist Archimedes in the 3rd century BC and relates buoyancy to displaced liquid. It states that an immersed body, completely or partially, is buoyed up by a force equal to the weight of the fluid it displaces. Archimedes' principle applies to gases and liquids. The displacement rule says a completely submerged object always displaces a volume of liquid equal to its own volume. An example, place a stone in a container that is brimful of water, and the amount of water overflow equals the volume of the stone. Weigh an object in air, then lower the object under the water and weigh it again. It will weigh less. The difference between the two weights is the buoyant upward force of the water. That is, the buoyant force is the upward force exerted on a submerged or partially submerged object. This is illustrated in the following example. If the 3 Newton block is submerged in water, it apparently weighs 1 Newton. Then the buoyant force and the weight of the water displaced is 2 newtons. The buoyant force is equal to the weight of the fluid displaced. It can also be understood by pressure differences. The greater pressure is against the bottom of the box, deeper in the water. The pressure at the bottom minus the pressure on top results in an upward force, the buoyant force. On which of these blocks submerged in water is the buoyant force greater? 1 kilogram of lead, 1 kilogram of aluminum, 1 kilogram of uranium, or all the same? Answer is B, the 1 kilogram of aluminum. The largest block is the aluminum one. It displaces more water and therefore experiences the greatest buoyant force. The principle of flotation is that a floating object displaces the weight of fluid equal to its own weight. Example, a solid 1-ton block may displace 1/8 ton of water and sink. The same 1 ton of iron in a bowl shape displaces a greater volume of water. The greater buoyant force allows it to float. Consider 500 kilograms of iron with a density of 7,874 kilograms per cubic meter in the shape of a sphere. A, how big is the sphere if the sphere is solid? And B, how big must a hollow sphere be to just float in seawater? The mass density of seawater is 1,023 kilograms per cubic meter. The weight of the iron is 4,900 newtons. The weight of the iron is also the volume of the iron times its mass density and the acceleration of gravity. The radius of the sphere then must be 0.25 meters, a diameter of half a meter. The weight of the iron is 4,900 newtons. The weight of the water displaced is the volume of water displaced times its mass density and the acceleration of gravity. Since the weight of the water must equal the weight of the iron, the radius of the sphere must be about 0.49 meters, a diameter of about 1 meter. The reason a person finds it easier to float in salt water compared with fresh water is that in salt water, A, the buoyant force is greater, B, a person feels less heavy. C, a smaller volume of water is displaced. D, none of the above. The answer is C, a smaller volume of water is displaced. A floating person has the same buoyant force, whatever the density of water. A person floats higher because a smaller volume of the denser salt water is displaced. On a boat ride, the skipper gives you a life preserver filled with lead pellets. When he sees the skeptical look on your face, he says that you'll experience a greater buoyant force if you fall overboard than your friend who wears styrofoam-filled preservers. A, he apparently doesn't know his physics. B, he is correct. Answer is B, he is correct. But what he doesn't tell you is you'll drown. Your life preserver will submerge and displace more water than those of your friends who float at the surface. Although the buoyant force on you will be greater, the net force downward is greater still. The Falkirk wheel in Scotland uses Archimedes' principle. Each of the two caissons weigh the same regardless of the weights of floating boats they carry. The water displaced equals the weight of the floating boat. Archimedes' principle applies to fluids, liquids, and gases alike. Force of air on the bottom of a balloon is greater than the force on top. Net horizontal forces cancel, but not vertical ones, which supplies the buoyant force. And this buoyant force equals the weight of displaced air. Is there a buoyant force acting on your classmates at this moment? Defend your answer. A, no. If they were, they would float upward. B, yes, but it is insignificant compared with their weights. C, only in water, but not in air. D, none of these.